Okay, this you minimize it. Maximize full screen. Okay. Okay. Start with the edit. So this is auto layout. Browse for the library file tanner.lib, Tanner database file TDB. So go for Tanner EDA, Tanner tools,Ledit and LV libraries. You can find generic underscore 025.tdb. Click OK, then open the file. Then go to grid, change its size, major display grid, setup design grid. Major display grid should be 0.25, minor display grid should be 0.25. Change the mouse grid cursor type to smooth, then click OK. Maximize the window. Now go for cell, copy, browse. Then from here go to go in search for auto layout folder. So for that purpose you have to go for VTU experiments. Under VTU experiments search for auto layout. Search for auto layout.tdb. So here you are going to get list of experiments. Select a particular experiment, click OK. Next, cell instance, select the experiment and click OK. So clicking on the screen you will get the experiment. So you have to remove this particular name. So this is saved as an image. So if you want to erase this, go to cell again, cell, flatten. So this is, you have to click yes. Then you can access these layers one by one. So you can view below its values at the corner here one by one. If you see on the left corner below, you are going to get the values for each layer in terms of dimensions, boxes. Next, active layer. Next for P select. Next for metal, active contact. Then save this design in that particular folder. Perform DRC to check there is no error. Next, setup extract, standard rule. Click the edit command. So search for the library file. So you have to go for documents. So you have to go for search Tanner EDA folder, which is available in C drive. Then Tanner tools. So libraries, under that you can find generic. So next you have to find the space for cell 0.spc. Browse. You have to paste it in a below. You have to paste it in the design folder. Go to my computer, then that particular design folder location NT4, and here you can save, but before saving you have to change the layout, auto layout spice file name. So give it as cell auto layout, save, then click on the output, delete this line, then click OK. Next, extract. So spice file will be generated. Then save this the particular design location. NT4 design folder, NT4, you have to save this. Rename it in the form of inverter. so that the experiment file can be known. Save it. Minimize this. So open the spice file from that location. Insert the cursor on the command and now insert the commands one after the other. Analysis, transient analysis, maximum time 10 nanoseconds, simulation 100 nanoseconds, insert command. Next, DC transfer sweep, sweep 1, sweep type linear, parameter source, source name V1, start 0, stop 5, increment 0.1, accept, insert command. Next, files, library, browse for library file, go to Tanner EDA folder, Tanner tools, libraries, generic, instead of generic go to models, you are going to get generic underscore 025. Next, TT, type TT, insert command. Voltage source, take bus here, not bus, bit, pulse, you can take it either pulse or bit. So here we are going to take pulse. Voltage source name V1, positive will be input, negative will be ground. Initial voltage 0, peak voltage 5, rise time 1 nanosecond, fall time 1 nanosecond, pulse width 10 nanosecond, pulse period 20 nanosecond, insert command. Next, constant V2, positive terminal VDD, next ground, DC 5 volts, insert command. Output, DC results, node name, type out and add to the graph, insert command. Next, transient results, and type input, add to the graph, type out, node name, add to the graph, insert command, close it, .op, type .op, save it and run simulation. Now wait for the result. Now you got the result for inverter. So the upper one is DC output and the below one is transient input as well as output. So select all. After selecting all, select the marker. Press home button so that it will be fitting to the exact voltage values, both low level as well as higher level.